Happy Wednesday, y'all. Um, it's time to get back into fifth grade math, and we are going to start by taking lesson one out of our book and starting to gauge in equivalent fractions. So today we're going to be working on equivalent fractions. So we're just renaming fractions to have different size units. So sometimes we make our units larger, sometimes we make our units smaller, and we'll go over that today. But we're going to show three different methods, and those methods hopefully are um, a review from fourth grade. These should have all been models that you've seen in fourth grade. If not, hopefully we'll take enough time for you to feel comfortable with them. I like these models. I wish I was taught fractions this way because it brings a visual piece to it that helps you understand fractions at a deeper level than we ever did as adults. Now, your parents, myself, we were taught tricks on how to do these equivalent fractions by multiplying and dividing and doing flips and stuff like that. But we're going to teach you exactly why we're doing things like that. So bear with me, parents, bear with me, students. We're going to show a lot of visuals to help us understand fractions in equivalency. So we're going to do three models. We're going to do, well, two visual models and then just working with numbers. So area model. So just drawing, a nice big square and working inside of that, a number line. So having a number line labeled nice and neat, trying to show those partitions as well. And then abstractly taking those ideas and then applying them to a number sentence. So that is what we're going to work on today. So let's get started. Let me minimize my face, get my stylus out. Happy Wednesday, by the way. We made it halfway through the first week back of 2021, and I'm excited to keep it going. All right, you guys are doing a great job. So module 3, lesson 1, we're almost a third of the way through. Well, we are a third of the way through the year. We're almost halfway through the year. So here we go. Let me get to a new page. So let's first start talking about the area model. Oops, let me get to the right page in my book. And they really wanted us to work with fraction strips. So me giving you a piece of paper, I don't have that. So let's go ahead and draw an area model. So first, just draw a nice square or a rectangle probably. Now, I want you to show me in this area model, represent 1/2. So I'd like you to represent 1/2. I'll give you a second to do that. And I'm going to do it like this. Now, you could have done it a horizontal cut, but let's have our first cut be a vertical cut. So we have 1/2 represented. Is there a way for us to break apart this area model to show a different set of numbers? Is this ringing the bell of what you need to do? And let me take one step. Could I have done this? Does that change my fraction? Well, it sure does, right? Instead of having one part of the whole, now there's two parts of the whole, but the whole is no longer just two parts. That went to 4 parts. Does everyone agree with that? This is now, instead of 2, or 1, I mean, it's now 2 parts, and this is another 2. So this now shows 2/4. But we showed with that area model that nothing changed to the overall value, that area model didn't get larger or big or smaller. The units got smaller, the pieces got smaller, but the overall total of it didn't change at all. So that's why we want to use the area model to represent that. But now let's show a math sentence that represents what we just did. So I'm going to change my color to, let's go yellow. I've already used yellow. Let me use red. And I'm going to write my sentence. Well, we started with 1/2. Now, what did we do? We used one line to cut it in how many pieces? Just think about, let me use my highlighter here. Just think about this part when I'm talking right now. We used one line to cut it in how many pieces? Well, we turned it into, yeah, that's 2 pieces now. So what we did is we multiplied the top by 2. Well, did we only cut the part that we have by 2, or did we cut the entirety, the whole by 2? Well, we cut the whole thing by 2 because we can see that over here as well. So we also multiplied that by 2. So when we're creating equivalent fractions, you're always going to have multiply the top by the same thing as the bottom, because when we are creating an equivalent fraction, you have to do the same thing to the entire piece, the entire number, the entire fraction, right? So if I cut my one part that I do have in half, I need to cut the other part that I don't have in half as well. So here we are. Now, what do we know? And I mentioned it in class the last couple of days. What do we know about a fraction that shows the same number over the same number? So the same denominator, same numerator is the same denominator, same number of parts as you have as wholes. Notice I changed the language multiple times so that everyone has an opportunity to understand it. But those are all words that can work for this. So really, 2 over 2, 3 over 3, 4 over 4 is always equal to 1. Mr. Sager just stopped by, so just say hi to him and let me pause. All right, so the fact that fraction, sorry, I got a little distracted with Mr. Sager, but now that's the fact that fraction is really 1. What do we know when we multiply anything by 1? It stays its same value. Well, in fractions, we can change the size of the units by doing this, but because we're really just multiplying by 1, we're not changing anything except the size of the pieces inside of the whole. So here we go. Well, we just multiply right across the top. Well, 1 times 2 is 2. And we see that over here. There's 2 parts in our area model. And when we multiply 2 by 2 at the bottom for our denominator, we now know that the whole has 4 parts altogether. And we can see that in our area model. So great job. So let's go on to show the same thing. Well, actually, let me back up. I'm sorry. Is there a way for us to use, can we cut that area model in any more ways to change it? And so I'm just going to quickly clear my page and quickly draw my area model that showed 1/2 again, and then represent. Is there a way to show something other than fourths? Is there any rule that says we only can cut it once? If you're at home thinking about a birthday cake or something, is there a specific number of rules of how many times you cut it? No. You need to cut it to equal as many people as you have in the house. So you can keep making equivalent cuts as long as you're following the rules of doing the same thing to the parts as the whole. So we can cut once, we can cut twice. So when we cut once, it created fourths. When we cut twice, what did it do? Well, it created 3 parts in each section, right? So this is really 3/6 now. So we showed that 1/2, 1/2 is equal to 3/6. But we can't just do 1/2 equals 3/6. We want to show what did we do to the fraction to get to 3/6. So this is accurate. That's what has happened. But there's one step I need you to take in between just to show your understanding. And that's going to be the step that goes inside of that circle. Well, we do 1/2 equals, and then we do 1/2 again because that's what we started with. And what did we multiply that 1/2 by? Well, how many cuts did we do? We did 2 cuts, but that created how many pieces? Well, that was 3 pieces. So we're multiplying the top by 3 and the bottom by 3. So 1 times 3 equals 3, 2 times 3 equals 6. So I know that you're going to be able to visualize and see the actual answer, that 3/6 is the answer when you draw your model. But I need to show the mathematical understanding about what did you do to that fraction of 1/2 to get to 3/6. Well, the same thing's true. We could have kept cutting, right? We could have cut more. Let me again, just really quickly. There's 1/2. I'm going to change colors. Now we created 2/4, right? There was our 3/6. What did I just create right now? Well, how many pieces do you have filled out? 4. And then there's another 4, so it would be 4/8, right? Could I cut again? Yeah, I could keep cutting as many times as I needed to, as long as I'm doing it to the parts and the whole. So same thing, doing the same thing to the top as the bottom, right? Now, don't multiply. I could have cut it 9 times to create 10 different spots, So 40/80ths is the same thing as 1/2 or the same thing as 4/8. Okay, so that's how we're going to use the area model to show it. How do we use the number line to show it? Now, some of you might prefer one model over the other, but we want to make sure that we understand how to use them all. So please make sure you give me a number line. And because we're working with fractions, we can just do a 0 holes to 1 hole. So let's go ahead and just place that on there. Now, let's go ahead and place that half mark. Now, with number lines, you don't have to be perfectly accurate, but you want to be reasonably accurate. So it's got to be about 1/2. So there's my 1/2 mark. Now, how do I show equivalencies to 1/2 now? How can I show, well, when we first did the area model, we went right to fourths. How can we do that? Well, we know that 2/4, because of our area model work, was the same thing as 1/2. So that must mean that there's one other piece between 0 holes and 1/2. So there's our 1/4, and would give us 3/4. I apologize because I think we should have been doing the area model alongside the number line. And do your best with the number line to represent it as you're doing the area model, and continue to work that. I'll make a few examples on the problem set. So I apologize that I messed that up. But let's try actually on a fraction greater than a whole. So let's go ahead and try to do it the right way with the area model. And I'm not actually, I keep changing my mind, and I apologize for that. But let's do an area model. Give me an area model that represents 2/3. So again, start with a vertical cut. So 2/3, I'm going to represent my 2/3 by filling them in. There's 1, there's 2. So I have a 2/3 represented area model. I would like us to try to show, oh, actually, before I go to 6, let's quickly create a number line. Wow, I can't talk. Show 0 holes at the beginning and 1 hole at the end. Also, make sure that those arrows on the end of are on the ends of our number line. That's an accurate mathematical concept. Lines go forever. Numbers can go forever. So we have our number line. I wanted you to represent 2/3. So what unit do you think we should represent on the number line? Do you think we should represent halves? Yeah, no. We're going to represent thirds. So again, you do not need to be perfectly accurate. You need to be reasonably accurate on the number line. Well, that would be 1/3. That would be 2/3. Where would 3/3 go? Yeah, that's 1 hole. So once again, 1 hole is the same numerator over the same denominator. Good. So if we showed represented 2/3 in the area model, that would be 2/3 right here on the number line. So now my question is, can we represent this as 6? So what I've just asked you to do is turn 2/3 into something that is 6. So some of you are able to visualize that instantly. Some of us, I want to set it up like this so you can think. Now, what you need to kind of think about is my whole went from thirds to 6. My units doubled. So what do I need to make sure I do? It went from 3 times 2. So remember, if we cut the whole in 2 pieces, then we are actually cutting the top or the parts into 2 pieces. So 2 times 2 would give us 4. And then that's exactly what we have. So once again, we now know that 2/3 is 4/6 on the number line. Sorry that that's bleeding into the area model. But how can I represent those other thirds? Well, what did we do to each part? Well, we cut each part in half. So if I just go ahead and say part here, That would be 1/6. But we have to make sure that the 6 count on the thirds as well, because each third is a 6th as well. So you just keep working your way, cutting each part in half. I got 1/6, 2/6, 3/6, 4/6. Here would be 5/6. Where would 6/6 go? Exactly. That's 1 whole. So could I now represent that as ninths? Is there a way for me to represent that as ninths? Yeah, we would just need to do one more cut. Our number line in our area model is getting a little too full, so let's go ahead and stop with that one. But I just wanted you to think about, can we do it one more time? Yep. Could we do it more times? Yep. So let's go ahead and try one that's a fraction greater than a whole. So if I ask you to draw me an area model that showed 5/4, let me write that fraction down so you can visualize it too. 5/4, a fraction greater than a whole. How are you going to do it? Well, I wanted an area model, right? So there's an area model. What's the unit? Well, the unit's fourths, so let's go ahead and make fourths. When it's an even unit, like, I gotta say, don't you just love when technology breaks on you? Oh my goodness, I just lost internet and my video stopped recording, and here I am ready to teach 5/4 again. So, and the worst thing is I didn't notice it for a good 5 minutes into explaining this question. So let's go again. Here we are, 5/4. So draw the area model. Let's represent fourths. Do you notice a problem that we're gonna have? Whoops, let me get my pen tool. Well, I can only represent 4/4 in that one area model. And I should have used a different color so that green didn't blend in with each other. Let me use black here. So that's 1 whole. So how can I represent 4/4? Yeah, this is where you're gonna need to draw another area model and show fourths in that as well, but only show 1/4 in this one. So now we have, this was 1 whole as well. So we have 2 whole area models, and we're showing 5/4 overall. Now the question is, and let's go ahead and show a number line, and then I'll ask that question. Should we just use 1 at the end? This is where we actually, let's bring that line backwards a little bit and put 1 here, because we know that this fraction that we're working with is actually greater than 1. So we're going to need to show an extra fourth over here, and that's going to be our 5/4 mark. But then let's go ahead and represent these as fourths: 1/4, 2/4, 3/4. Let's go ahead and now think about, can we create fourths into eighths? Well, yeah, this is what we've been doing. We're going to cut the parts in half. We're going to go from fourths to 8. We're doubling the unit, so we need to cut each part into 2. And now we can see the entirety of it has been cut into 2. So now if we think about how many pieces we have, well, that's 1, 2, 3, 4, 5, 6, 7, 8. This is now 8/8. 4/4 became 8/8. That makes sense. It's 1 whole. We've changed them into eighths. We should have 8 of them. And then over here, the extra fourth that we had turns into 2/8. So overall, this is 10/8. Okay. Now let's show that as that mathematical sentence that I want to see. We started with 5/4. Well, 5/4, what did we do to the 5/4? We multiplied it by, well, each part got cut into half. So we multiplied by 2 halves. So remember, this is where we're creating an equivalent fraction. 2 halves is really equal to 1. So we're really not changing it. We're just changing the size of the parts and the size of the units. So 5 times 2 is 10, and 4 times 2 is 8. So mathematically, with a number sentence, we just proved what we did in the area model. Perfect. Now let's go ahead and represent that, those units and that equivalency on our number line. Well, we know that every 1/4 is 2/8. So we cut every fourth in half. So let me just go ahead and cut each fourth in half. But now, remember, when fourths are also eighths, and because every fourth is 2/8. So we want them also, when we're counting our eighths, also stop on those tick marks for the fourths so that we can include them. So let's go ahead and I'm going to label the 10th or the eighths, I'm sorry, on the top of my number line. So that's 1/8 right here. Our fourths are going to also be eighths. And then we just keep counting up. 4/8, so that makes sense on the halfway mark. 2/4, 4/8, that's half. Here we go. 6/8, that makes sense. Double the parts of 3. 3 times 2 is 6. 4 times 2 is 8. Yep. 7/8. 8/8 on the whole mark. That makes sense. And also, I should have represented that as also 4/4, right? And then we got 9/8 between 1 whole and 5/4, and then 10/8 on the 5/4, which again proves what we were doing mathematically. All right. So now I'm going to have to stop this video, stitch these two videos together. I apologize. It's going to be like a 20-minute video, but let me know. I didn't get much feedback on whether you like me not doing a problem set video or if you just like the problem set answers. I haven't seen a change in skill ability, so I feel like maybe just the answers are working. So I'm going to continue to post the answers until I hear otherwise from you guys that you'd like more from that. All right. So thank you guys. Nice job. Good luck today, Wednesday, and I will see you tomorrow if you're an Alpha. I'll see you Friday if you're Omega. Hopefully, I see you today at 1:20 for our Zoom, and have a wonderful day.